So, good morning again. If you have any questions about the homework problems, I believe you should be able to do problems from 2.1, first section. Today, the plan is to start 2.2. It's a hard concept, and the stuff we are going to go over is a difficult idea. And one more thing that sounds terrible. If you don't get this, you're not going to get anything else we do in this class. So try to get it. I'll be happy to go over it twice, three times. This is the building block of trig, and you really want to understand it. And it's not an easy concept. It's not something you're used to. Okay. Some of the things I'm going to talk about, you have seen some of them in bits and pieces elsewhere. But the way things work here, it's really a new way of thinking. Having said that, once again, if you have questions from MATLAB, you can always email me, but be very precise. I am teaching 3 courses. Mention your course name, okay? And give me a clear screenshot of your problem, as clear as possible, okay? If you just tell me the number, if you just tell me 2.1 number 5, I'll go there, but I'll do the one I see. They show me one problem, they show you, all of you see a different problem. So be aware of that. If you want me to do something very specific, give me a screenshot. If you just want me to do a problem like the one you're struggling with, you can give me the number. I'll be happy to do it. And when somebody asks me to do something, that's the first thing I'll start our class with. And once again, we are recording. Those of you who are here, you can interrupt anytime. Not a problem. Mute yourself, because when I say something, it goes back to you and it comes back to the whole group. It doesn't help. Okay. Well, thank you for coming to class, guys. So again, be a little patient. Okay. Be a little patient. And this is crucial for the rest of the course. The ideas that we are going to present will come back over and over again, practically every day. Okay. All right. So here we go. A unit circle, this is a unit circle, which is simply a circle whose radius is 1. This radius PC is 1. I know this is, we are going to always start from here, go like this, always. And if we do that, we're going to say this angle is positive. All right, we generally label it like this. Now, if we choose to go this way, this angle will be deemed or called negative. And we kind of discussed that. We said, if you're going counterclockwise, the angle is positive. If you're going clockwise, the angle is negative. Why do we do it? I don't know. That's how we do it. Now, today, we're not going to worry about going back unless we run into a problem where they want us to go back. All right. So this circle that you see, I know it's partly red, partly blue, but don't worry about the colors yet. This is the terminal radius, terminal line, and this is the original line. We always start with this line, actually, CA. We always start here, always. Okay, we go this way or this way, doesn't matter, we start here. So again, this is all review. What's so new about it? Nothing. Now, this is a unit circle. Its center is at the origin. What's the origin? This is the x-axis. I'm going to gently write it here. It's not that important. This is the y-axis. This is the plus side of the y-axis. This is the minus side of the y-axis. This is the positive leg of the x-axis. This is the negative leg of the x-axis. Again, you guys know these things. Nothing too fancy. Now, if that's the case, if this is a unit circle, let's write it down, unit circle. Just for our own sake, unit circle. This circle you see is a unit circle and C is the origin. Let's write that down as well. The center, C is the origin, and the coordinates of the origin are 0, 0. Sure. Again, nothing too surprising. Now, this point, the coordinates of this point are 1 and 0. Hence, the coordinates of this point, point C, let's call this X, guys. I don't want 2 C's, okay? Let's call the center, let me see what, let's just call it O. Okay, let's call the center O. More traditional, origin O. All right, the coordinates of point C are -1 and 0. And the coordinates of point B are 0 and -1. First one is the x coordinate, the second one is the y coordinate. And obviously, if you know B, D is going to be 0 and -1. If you know the coordinates of A, which is 1 and 0, x coordinate is 0, y coordinate is, sorry, x coordinate is 1, y coordinate is 0. You know the x coordinates of point C and the y coordinate of point C are going to be -1 and 0. Again, this is nothing fancy, something you have done in high school many times, probably even in middle school, the very basic stuff. Now, here today, we're going to first define sine of an angle theta and cosine of an angle theta. And you really want to get this, okay? So we are going to pretend this red line is a rope. Pretend it's a rope attached to point A. It's a rope. And we're going to try to wrap W-R-A-P, wrap this rope around this circle in this direction, where we will actually wrap it like this too, but we're not going to worry about it today. Don't worry about it. Again, the direction, how we are wrapping it up, I don't know if you can see me. Let me see if I can do some hand gesture. So you're going to wrap it up like this, okay? Why do we do it? That's how it's defined, okay? And it's strange, okay? It's very strange, very bizarre, no question about it, but it works. It does a lot of good things for us, okay? That's why we do things that are sometimes bizarre in math. You're going to wrap this rope up, and you're asking, how far would it go? Well, if the rope is very short, it's going to kind of stay here, right? Depending on how short it is. But if you take a longer rope, it may even fall here. I'm not going to worry about the rope anymore. I'm not going to write it. Again, this red line around the circle is a flexible rope of a specific length. And let's say if it falls here. Now, in last class, we discussed this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. So I'm going to refer to these areas as quadrants. And again, we start with the quadrant. That's both x and y are positive, and go counterclockwise. I'm not going to, well, I can leave them here. Well, no, it's a little bit of a distraction. I'm going to erase it, guys, if you don't mind. Again, if you don't understand what I'm saying, if you want me to explain something again, please ask. Again, I have a rope. This rope ends at this point. Let's make this point green so that it stands out. Green. This green point is where this red rope, when wrapped around this very unit circle, ends. Now, the x-coordinate of this point is called, let's suppose this angle, if this length is whatever you call this length, t, maybe this rope's length is t, t as in toy, okay? And the coordinates of this point P, let's say, are x and y. I don't know what x is, I don't know what y is, but I do know they're in the first quadrant, so they are supposed to be positive, right? All right. Now, and let's write it down nicely, guys, because I want to hang on to it. Let's say the coordinates of point P are x and y. And the length of this length is p. P as in toy. YG, doesn't matter. You could have called it P, doesn't matter. Now, depending on what X and Y are, this X has a second name. This X has a second name. We're going to call it sine T. Sine T is Y. Let's just write cosine T first. Cosine T is X. Okay. Again, this is very, very important. Let's put it like this. Let's pause it a little bit. And you really want to get how we are defining sine and cosine. We have I'm going to summarize it once again. We have a unit circle. What's a unit circle? A circle with radius 1. And this unit circle has its center at origin. What's the origin? Origin is the point where the x-coordinate is 0 and the y-coordinate is 0. Now we do something very strange. At the point A, we try to wrap a flexible rope, like you're wrapping a rope around the trunk of a tree. Assume the tree trunk has a perfectly circular cross section. We're just doing it. Just bear with us, okay? Now, if you wrap this rope, depending on the length of the rope, it will fall here. Let's say it's short enough to be in the first quadrant. Once your endpoint of your rope, one endpoint is here, at point A. I'm talking about the other endpoint, okay? The other endpoint, if the coordinates of this point are x and y, we say cosine of this t is x, and the sine of the same t, sine t is y. That's how we define sine and cosine. Let's pause here a little bit. I'll give you good 1 minute, okay? I don't have a good timer here, but I'll try to give you a good 1 minute to process it and maybe ask a couple of questions, okay? I know it's an online class. I have no clue what you guys are doing, but if we have 2 or 3 people who are following and that they're going to ask a good question, everybody will benefit. People who are going to watch it online later, they'll benefit and all that. I'm going to assume it makes sense to you guys. You don't have too many questions, but this is again very important. You want to understand it. One more tiny thing we're going to go over that's also important. If this length, remember in section 1, chapter 2, we talked about arc length. So this arc length is E. If this angle is theta in radian, oh, let's write it nicely. If this angle is theta, if this angle is theta, it's going to be positive because you're going from A to P, which will make it positive. You're going counterclockwise. What's the relationship between theta and T? Okay, they're always going to be the same. I'll show you right now. Remember that famous formula? S is equal to R theta that we worked on when you did your homework problems. Okay, R is 1 because this is a unit circle. And good news for us, 1 times theta is 1. And S, we're calling it T. So once again, if this is a unit circle, if this is the origin, whatever the length of your rope is, magically, it turns out to be exactly same as the angle in radian. Again, it's very important to measure angle in radian. What's radian? Well, it's about 60 degrees, but it's a better way of saying is pi radian is equal to 180 degrees. That's a better way to keep it straight, okay? So how do we feel, guys? Anybody feels okay? How do we feel? Anybody just tell me if they understand it?
I understand.
Good, good. It's a little rough. And look, and I thank you for talking. Josh, I believe you talked. The catch is whoever gets it for the first time, encounters it for the first time is perplexed. Okay, and it's a different way of thinking. Why am I telling you this? because you will be a little puzzled. You'll be a little challenged, but you're not alone. Everybody goes through that. If you don't, you're probably, if you had trig, you're good. You're fine. You get it. If you didn't have trig and you are like a little perplexed, you're supposed to be a little perplexed. Now, let's see what else is in your notes, okay? So I have your notes here. Okay, so this one, guys, okay, your book does it this way. You can read it. They're doing the exact same thing that I did. I used a software that where things can be moved. So that's a little better, I would say. But take a look at this picture. That's exactly what I explained. And they are doing it from the negative side too. We're going to get to it when we get to it. I'm not going to worry about it yet. The sine function is the y coordinate. The cosine function is the x coordinate. Let's see, I didn't mess it up. Sine is y, cosine is x. I sometimes I mess it up, but you want to keep it straight. Cosine is the x coordinate. Sine is the y coordinate. Now, having said that, the rest, this is the hardest thing we're going to do today. Okay, and you do want to get it. Again, I'm repeating myself. If you don't get this, you won't get anything else. But now what we're going to say is really not that difficult. Okay. So tan of t. So based on what we just defined, I'm going to go to my usual where I do my work. Okay. So let me grab this. Give me 1 second. I don't need this. It's a little redundant. Okay, let me grab this picture and go to my usual environment. All right. So we have discussed it. Okay, fine. Based on sine and cosine, we're going to define a bunch of other functions. Okay, they do come in handy different times. So we're going to define it today. Again, the good news is everything should be in your notes. Okay, and write things down. A tip would be open your book. Okay, take the things that are in the boxes that I'm going over. I am going over most of the things in the boxes of your sections. Okay, put them in a Word document and keep that Word document handy, available during your exam. And you won't be able to go back to the book. You'll have access to the book, but you won't be able to go back to the book and sift things. You won't be able to. All right. So what is tan theta? We're going to now define tan theta. Once I know what cosine theta is, sine theta is, we're going to say t here, okay? Sometimes we say theta because remember, guys, 2 seconds ago I showed you this angle is theta in radian. This is t. They will always be the same. So sometime I might accidentally say theta. That's what I mean because they're going to be the same. Why are they going to be the same? Because the radius is 1. What's tan t? We're going to stick to t today, okay? This is our day 1. Is sine t divided by cosine t. That's how they define it. Whatever, if you know what sine t is, I tell you sine t is 0.3, cosine t is 0.25, whatever, I'm making it up. You have to find tan t, you just take sine t divided by cosine t, and you got it. All right, there is another one. The other one is cotangent t. Okay, by the way, this is, I'm going to write cot. I'm going to tell you what it is. Cotangent. I'm going to write the words today, okay? But we're going to not worry about it. I'm going to tell you what I mean in a second. Today, I'm going to write each word in full, okay? In a second. All right, so cotangent t is the reciprocal of tan t. Tan is actually tangent. Let's write it down. These are the words I'm using. Tangent, cotangent, and we'll come up with, we'll run into this word secant and cosecant, just those 4 more. Secant, cosecant. Okay, just those 4 words. Okay, we don't write tangent generally. We say tan. We don't write cotangent. We say cot. We don't write secant. We say sec, S-E-C. We don't write cosecant. We write C-S-C. They don't write COS for obvious reasons because they don't want you to think it's cosine. So cosecant is written co-CSC. Okay, those are the notations we're going to use. Now, I'm not going to write this every single day, okay? Okay, again, if tangent is defined as sine over cosine, cotangent is defined as cosine over sine. And they're called reciprocals, another fancy word you must have heard, I know. Reciprocals. What are reciprocals, guys? They're just flipped. The numerator becomes the denominator becomes the numerator. For instance, these two numbers are called reciprocals of one another. Okay, because they're just switched. What about these two numbers? They're reciprocals of one another because this is 1 over 2, this is 2 over 1. Remember, guys, there's a little 1 here. So they're really flipped. So that's what we mean by reciprocals. Now, that's not that important, except for we need to know it. I'm going to delete this. Two more. There's a reason why I have the word secant, okay? Secant t is simply the reciprocal of cosine t. And cosecant t, you can almost guess, cosecant t is the reciprocal of sine t. If sine t is half, cosecant t will be reciprocal of half is 2. If cosine t is 1/3, secant t is going to be 3 over 1 or 3. And again, the way I keep it straight, guys, and you're wondering, oh, I'll have my notes out. But if you just count on everything that's in your notes, you won't be able to do the problem. You won't understand the problem. So S and C are reciprocal, and C and S are reciprocal. Okay, don't assume the reciprocal of sine is secant. No, the reciprocal of sine is cosecant, and the reciprocal of cosine is secant. And yes, you have to remember this. You don't have a lot of choice. You have to remember this, and you have to remember this. And they're just reciprocals of each other. Okay, this is the reciprocal of that, and this is the reciprocal of that. So we have our 6 ratios. 2 of them are elementary, sine and cosine. And just one more fact, if this is t, 3 inches, 2 inches doesn't matter. And if this is the angle this endpoint makes with the center is in radian, they're going to be numerically the same no matter what. And that's why we studied some of the things we studied in 2.1 to make this complicated thing relatively simple. Okay? I'm going to pause there just a little bit. Okay, guys? Mostly for you guys, not necessarily for me. Awesome, guys. Seems like we are ready to do some of the problems. We should be able to do them. All right. So, guys, it's not a bad time to get out of this session and come back ASAP. Okay. We're going to start solving some problems from 2.1. And I would like to believe by the end of the day, you should be able to do all the problems from 2.1. If we don't wrap up all the little chunks, that's okay. I'll tell you, oh, well, I have to finish some more. So I'll see you really soon. I'm not going anywhere. I'll be back in 15 seconds. Bye-bye for now.